Hello everyone, this is 𝐿𝐸𝐿 𝐂𝐿 and today we are discussing one of the focused item how you can make actually highly available systems. There are some things which you have to consider if you are considering to make your system highly available. So we will be taking the example of how you can make the highly available system with Amazon Kinesis Data Stream, and we will discuss how if your system is, let's say, deployed in specific cloud, let's say this is your AWS cloud environment and you are deploying something here. Okay, now to ensure if some of the resources goes down, how you can ensure that the system is operational, the system is available to solve the customer queries. So there are multiple concepts, right? One is you launch the resources in multiple availability zones, and either the second thing is you launch the resources in multiple regions. So we will be discussing this example specifically, that if you replicate the resources in multiple regions, then you can try to, or you will some sort of will able to make your systems fault tolerant. Okay, we will not be focusing much on the actual concepts around like AWS and all. We will try to generate a general picture on how you can generally make the systems highly available, right? So but since this video is the content is specific to Amazon Kinesis Data Streams, I will give you a quick overview about what Amazon Kinesis Data Streams are. So consider a scenario that there are some events which are being published. Okay, now let's say that these are your mobile devices, this is your computer device. So there are multiple users which are interacting with your application. This is your app. Okay, now there are multiple users who are interacting with your application. Now what you want to do is you want to capture the actions, how the users are responding to your UI. Okay, so let's say there is some like button. Let's say this is your Instagram application, there is like button, there is share button, or there is some view button. Okay, so if you go to a particular photo in Instagram, are you looking for all the photos in that gallery? Okay, there are let's say a person published 3 photos. Now did you just look into one photo, or did you look into multiple photos? So these kind of events you want to capture, so that if you capture those events, you can do further analysis, and then you will be able to recommend further photos basis of the interest. Okay, yeah, this is the person is interested in these kind of things, so let's show him more, something like this. So what you want to do is, our use case is that you want to capture all these events into your backend system so that you can run the analysis, and this you want to do in real time. Okay, so what you are looking for is there are events which are streamed in real time, we can say near real time. Okay, nothing is real time per se, but near real time, and they are streamed, and you want to capture all these events and then further consumed by your system. So this is where you can use Kinesis data streams. One another solution you might have heard of is Kafka streaming solution, right? They are kind of similar, only Amazon also provides, AWS also provides managed streaming Kafka solution, Amazon MSK. But just in context of this video, I will give you a quick gist about Kinesis Data Stream. So you got the idea, right? There are some devices which are publishing the event, so they are kind of producers. Okay, now this is your Kinesis Data Stream. You can assume it is a kind of queue, not queue actually, but you can assume it with storage up to 1 year. Got it? And then you have consumers which can consume these events for any required action. Okay, so this is whole idea about Amazon Kinesis. Now let's move further with our discussion on how you can build highly available streams with Amazon Kinesis Data Streams. So what we are ensuring is we have to make the system highly available. Now when we make the system highly available, there are two main things which have to be considered. First one is RTO and second one is RPO. First one is RTO and second one is RPO. What we mean by RTO? RTO is recovery time objective, and it is the maximum acceptable delay between the interruption of service and restoration of service. So let's say this is your service, it goes down at T1 and it comes back at T2. So the difference T2 minus T1 is referred to as recovery time objective. And if we talk about recovery point objective, this is in concern to, do you have the ability to lose any data? Okay, so RPO is the maximum acceptable amount of time since the last data recovery point. Okay, so this determines what is the considered an acceptable loss of data between the last recovery point and interruption of service. So in this similar time, okay, T2 minus T1, what is the amount of data that you can lose, and if you lose, will you be able to are you okay with it? Okay, so that is the thing which are considered by RTO and RPO. And what we want to do is we want to ensure that this is minimum. If this is minimum, then your system will be maximum available. In general sense, the lower your value of RPO and RTO, the more expensive the overall solution becomes. Why? Because to ensure the lower value of this, you will have to do certain kind of replication at all the stages of your application or the resources, however you have architected your system. And since you are replicating the resources across the regions or across the availability zones or whatever you are doing, you are introducing some kind of failure mechanisms, and that's what makes the solution expensive, as in your cloud billing paisa zyada lagega, right? So that's the thing. You have to decide what like whenever you are designing the systems, you have to come up with these values. What is the time that I can sustain, like how badly, like in case my customers are impacted, how what is the time that I am looking for, that if I recover in this time, I will be okay with it. Okay, so this is the general idea, and the higher the values RPO, the more complexity you introduce in failure mechanism. What we mean by this is, so let's say in your solution, you developed some kind of system. Okay, you developed this kind of system. Now let's say you have the RPO value higher and higher, RTO value higher. Okay, now let's say some issue occurred in this system. When we say these are higher, that means that you don't have any replication in place, similar architecture in place, which can be used in case of failure in this system. Let's say this system goes available, they should come up online. But if you don't have such configuration, so in case some failures occur, you will have to have some kind of complex mechanism to make this system come up, or introduce some kind of mechanism so that you are able to do it. But definitely it will be complex. That's what our whole point is, that the higher the value of RPO and RTO, the more complexity you introduce in your failure mechanism. Got it? Now let's move further. In this specific video, we will be taking one example and specifically introducing the failover architecture for every component. What we are doing here is we are specifically discussing around Amazon Kinesis Data Stream. If it goes down, what will happen? But there can be multiple components in architecture, right? So we have to think of what if every of these component goes down. But we will be discussing one of these components, and you will get the general idea how we should actually do it, or like what's the way forward to go about it. So the simplest approach for high availability is to start a new instance of producers, consumers, and data. Okay. If we quickly go through the diagram first, so let's take the example on how you want to do it. So this is your mobile device, and this mobile device publishes stock ticker information. Okay, now this is consumed by AWS Lambda producer. This is producing this is consumed by Kinesis Data Stream, and there can be multiple consumers, and finally it is stored in the Amazon DynamoDB for any further analysis. Okay, so this is the architecture we are looking at. So because now simplest, I believe you got the general idea. Now let's try to discuss some of the things around it. Now the simplest approach to high availability is to start a new instance of producer, consumers, and data streams in new region upon service and availability detection. The benefit here is primary cost, but your RPO values will be higher as a result. This is the thing which we discussed here, right? So what we are suggesting here is, like, as the things go down in this particular architecture, then what you will do, you will launch the resources here. Okay, you might have some cloud formation templates, or you are maintaining AWS CDK code so that you can replicate the resources in another region. But the resources launch will take time, right? And if there is some kind of state managed, or there's some database involved, so you will have to have that state in that database as well. So it can definitely take more time, and it will eventually lead to your higher RPO and RTO values, because they are spun after downtime detection. RTO time required to spawn up in parallel infra, and RPO, since there is no data replication, you will have to have, I don't know what we will do, but if we don't have that, it will definitely take more time. And if it's a stateless state system, then you will require some kind of mechanism where you maintain the state of the system. If it's stateless, then definitely you can survive, right? Now there are two ways to go about it. like what are the general idea around how you can make your system highly available. So there are two ideas, one is warm standby and one is cold standby. When I say standby, as in we have the parallel infrastructure but it is running all the time. If it's running all the time, it's a warm standby. If it's not running all the time, it's cold standby. Cold standby as in that we have the infrastructure in place, it's just that it's not running right now. Let's say you have some kind of EC2 instances, okay, you have some kind of EC2 instances but right now they are stopped. But as soon as we detect that the other system is unavailable in another region, in region A, then what we will do, we will start these instances in region B. So this is what we mean by cold standby. And warm standby means all of your resources are running all the time, so this consumer is running all the time. Okay, so active replication of data from data stream to region B, but consumers of data stream in region B are stood up when the outage of this region detected. This is cold standby. And in case of warm standby, consumers of data stream are running in both the regions at all times. This is the architecture we discussed. For high availability purposes, these use cases need to replicate data across regions, right, in the way to consumers and producers of data stream to fail over quickly upon detection. So this is the general idea we discussed, right, that if a system goes down in a particular region, then we need a sort of failover mechanism so that the architecture comes online in the another region to serve the traffic for the customers. So we are storing the data into DynamoDB for querying, alerting and reporting. So this is the idea this is the example which we will be discussing in this architecture, that what if this Amazon Kinesis system goes down, what will happen and how will you solve that. Let's change the color of pen and let's use red, looks good. Okay, so in our idea, I mentioned that we have to come up with the values of RTO and RPO, right? What are the values of RTO and RPO that you can sustain? So for our requirements specifically, the customer can withstand an RTO of 15 minutes. So this is the time for RTO, like T1 minus T2 for when the systems come back online. Okay, this is the time for RTO. And because the refresh end users dashboard on 15 minutes interval, the customer is sensitive to downtime and data loss because the data will be used for historical adulting post. So ideally your RTO is 15 minutes and your RPO should be as less as possible. Okay, so this is the general idea we are looking at, that for designing the failure mechanism in this system, we have RTO of 15 minutes and let's say RPO of within the seconds and like very less. Now let's discuss two of our patterns in more details. One is a warm standby and second one is cold standby. So in case of warm standby, what we are saying is you have this architecture here, complete architecture, and this architecture has a replication in between. This replication will publish the data to Amazon Kinesis stream in different regions. This is US East 1, this is US West 1, and your consumers are running all the time and they are publishing the state to DynamoDB. So in case there is issue occurs, let's say this Kinesis stream goes down, AWS Lambda will turn over to the Kinesis data stream in region 2 and the traffic will be served via this, or like these consumers will maintain the state so as to serve their customers. Got it? Now as we mentioned that your consumers are running in parallel on both of the regions, they are running in both of the systems, and this replicator can be anything, right? We will be discussing around if we use AWS Lambda, then how it looks like, but it could be anything. It could be your AWS Lambda, it could be your EC2 instance. What it essentially do is it essentially replicates the data, like whatever events you got, it publishes those events to Amazon Kinesis data streams here, and then they are consumed by consumers, and then the state is finally moved to DynamoDB for storage, where we can use it for any kind of alerting or querying or any kind of analysis which we want to do. Got it? So this is the idea around warm standby. Now the warm standby architectural pattern involves running in both the primary and secondary region. Okay, this we already discussed. Sources are configured to automatically. Okay, so this is the like what we say, in this architecture all your services, all the components are always online, and it's just that we have mechanism in place so that whenever there is a failure occurred, whenever we detect an unavailability scenario, then we will redirect our customers or redirect our consumers, redirect our producers to publish data to region B. So data is replicated across regions from data stream in a primary region to secondary region. This is done instead having a sources published to both regions to avoid any consistency issues between the streams in two regions. Okay, so what we are doing is data is replicated and it is consumed by Kinesis Data Streams, and then you have the same architecture which you have in reason 1. Now this is also most expensive. We discussed, right, that warm standby solution is the most expensive solution, and it's also the best one. So right, we in system design, it's always about trade-offs, like what is the maximum time that you can sustain if the system goes unavailable. The availability will never be 100%. It's just a myth. You can never ensure availability to 100%. The most available systems, let's say AWS DynamoDB, they also provides some nines of availability. It's never 100%, right? So there can always be downtime, but what we have to ensure is that we are available maximum of the time. Got it? So let's move forward with our just one consideration before we move to another approach. For business needs that can't tolerate this level of record unavailability, consider retaining data on the producer. So this is the thing around, like, what if, let's say this Kinesis goes down and the data was not replicated in that time. Okay, so the data is still present here. It was not replicated to this Kinesis streams. So in a certain time, like T2 minus T1, there was some data stream, let's say 5 records which were not published, and you might have those records missing here. So what is the suggestion is you retain those records on producer unless you got an acknowledgement, right? So this again depends on the requirement. If we have such requirements, you can republish the data from producer so that it can be used further. Now let's move forward with a cold standby pattern. In what we are doing specifically in this, we generally got that idea. We got the general idea that what we are doing here is this consumer is standby, right? The reason in reason 2, the consumers which are running on standby mode. They are not actually running. They are in stopped state. Okay. So whenever we detect a failover in the system, whenever we detect that the Kinesis data stream is not available, then the data will be stored via this Kinesis streams, and these consumers will go online and they will be stopped. And the DynamoDB, we are using here global table, so we are not using our own replication mechanism in the DynamoDB. We can use the feature of global tables. Global table is essentially that the table is available in all the regions which we want. So Amazon DynamoDB will hold the responsibility of replication of data. So let's say this is T1, this is T2. So the data will be synced or replicated by that, like it will be the responsibility of DynamoDB to replicate the data. We don't have to introduce another application here as well. Similar to here, we have introduced the replicator. So the cold standby architectural pattern involves running a data stream both in the primary and secondary region and spinning up the downstream sources like stream, consumer, and destination for streams when a service interruption is detected. This we already discussed, that consumers will only be up online when the systems in or Kinesis data streams in region 1 will go down. This is definitely cost efficient. Why this is cost efficient? Because the consumers are not always running. We are only running the consumers when they are required. So the primary benefit is the cost efficiency by not running consumers at all times, and like definitely if the consumers are not running, then you are not paying for that time. However, this pattern may introduce some data unavailability for downstream system while the secondary region infrastructure is provisioned. Okay, so there can be some time which is involved to come, like this infrastructure to come back, right? Because the consumers are not running, and let's say you figured out that there is some issue going on with this Amazon Kinesis data stream, then you will invoke a logic so that these consumers come back, not come back as in they are provisioned. So there is some time required to provision these resources, and the data unavailability issue can occur in that time. Okay, so it may take some time for consumers to reprocess the data in secondary region, and latency can be introduced when failing over. This is the idea. We understand that the data can be accumulated here till the time that your consumers are provisioned, and you might see some kind of latency. Now let's discuss around which patterns make sense for our use case specifically. Again, like as we said, always as we mentioned in the videos, in system design there is no perfect solution, right? We have to think around our requirements, that what are our requirements specifically, right? Like this is the requirement that I am looking at, or this is the most prioritized requirement for my use case. According to these requirements, there is a certain architecture that makes more sense than the another, right? And according to that, we make trade-offs. There will be no sort of solution which has 100% pros and no cons, right? There will be always associated pros, and there will always be associated cons. So we have to go back, or we have to go with a system which makes best sense for our use case. So if we go back to our use case, we mentioned that your RTO can be till 15 minutes and your RPO is like very less as possible. Okay, tell us that RPO is close to 0 and RTO is equal to 15 minutes. So in this case, we can determine that the cold standby architecture provides limited data loss and maximum downtime will be determined by the time it provisions. Okay, this we understood, right? So the maximum time which it can take is that what is the time of consumers, what is the time taken by consumers to come back. So this can be the time when the system is not available, but I think we can sustain till 15 minutes. So it should be good if we have proper configurations in place, that let's say we are using CloudFormation template, so it should be good enough so that your resources are coming up in 15 minutes. It's a good enough time to come resources to provision. It generally take that much of time. It generally takes, I think, 2 to 3 minutes and the resources are being provisioned. If you want to, by the way, try the architecture by yourself, in this architecture I will be sharing this article with you in the video description, and there is actually templates provided, CloudFormation templates provided and related code which you can use to replicate the scenario at your end. Now let's move to another scenario of replication, data replication specifically. Not data replication as in the lambda which we are introducing, the replicator which we are introducing, which will replicate the stream data from Kinesis data stream in region 1 to region 2. Okay, so the replicator will be acting as a kind of replicator service responsible for copying the data between the two streams, maintaining a relatively low latency to replicate and ensuring data isn't lost during the replication. And there is extra suggestion which is again related to Kinesis data streams only. So in general, if we talk about Kinesis, right, Kinesis has a fixed limit. Let's say this is your Kinesis stream and these are your consumers. So there is a fixed limit, like what is the amount that is being consumed by the consumer. So it's, I think, 2 MB per second. If it's more than that, and it's for all the consumers combined. Okay, for this particular Kinesis data stream, it is combinedly 2 MB per second. So if there are a lot of consumers, what is suggested is that you use enhanced fan out. It means that every consumer is given 2 MB per second. So this is basically to reduce the latency. Okay, and for the replication strategy, we are using the asynchronous replication. Now this is the diagram which is shown here, that this is the consumer application which was running here. If it goes down, then replication, basically the replication will be replicating the data here. Now Lambda replication. Now Lambda can treat a Kinesis data stream as an event source which will funnel events from your data stream into a Lambda function. The Lambda function then receives and forwards these events across region to your data stream in the second. This again, I think we already discussed that. I don't want to rediscuss the same things. What we are doing is we are taking the Lambda as a replicator in between, and this replicator ensures that whatever comes in there, it is sent to the Kinesis data stream in the region 2, and there are mechanisms which are available with the Lambda which we can use so that you don't lose the data when you are actually replicating from Kinesis data stream in region 1 to region 2. What you can do, you can introduce retries. Okay, you can have an error functionality, you can use Lambda parallelization. You can define that this is the capacity I need so that to parallelize that you do not face cold start issues in case of Lambda. So these are the all things which you can do when you are using Lambda. Definitely you can use another compute options as well, such as EC2 or ECS Fargate, but looking at the solution here, it's good to go by Lambda, and if your future requirements evolve, then you can think of other solutions. Okay, now this is the related code which we will be not going through, but definitely if you want, you can go through it, and you can also try this architecture at your end in your AWS account. Now around what if, like, how will you detect specifically, like when the service goes down, right? You will have to have some kind of mechanism which will figure out, okay, so this Kinesis data stream is not available, now let's switch to region 2. So how will you detect that? You can detect that by using the CloudWatch metrics, health check metrics. Okay, so if there is some, let's say you are putting the records into the Kinesis data stream and those records are not successful, the putting records API is not successful, so you will get some kind of exception, right? 500 exception, internal server exception, that there is some issue with the Amazon Kinesis data stream and you should either retry. So what you can do, you can generally retry, and if for certain time, let's say for 5 minutes, the Kinesis data stream do not come back online, then what you can do, you can go to the system to go to the region 2. So this is the again the time can be anything. 5 minutes time is good enough to ensure okay the Kinesis data stream in region 1 is not responding, so let's switch over to region 2 for ensuring it. Now let's discuss around client failover. How will you change the destination specifically from region 1 to region 2? This is region 1, this is region 2. So you will have to introduce the client failover as well. Once you have checked, 𝐻𝐢𝐭 checks this, okay, the system is unavailable, the Kinesis data stream is unavailable, so you will have to failover to region 2. What you can do, you can change the data stream location where the producer was writing, and this you can actually do it via configuring your CloudFormation template so that your resources are provisioned there. Prior to failover, the producer may have been delivering data to stream in region A, but we now have to automatically update the destination of stream to region B. Okay, and this all you can do via your templates which you configure. Definitely you will require automation here. I don't want to do it manually. So as soon as there is alarm configured or there is the put records issue we observed on the internal server exceptions we encountered, then our system should move to the region 2. Now for our use case, we use maximum again, these are related to what are the things you can do so that the configurations which you are maintaining takes the sufficient enough time so that you do not exceed that 15 minutes of RTO time, right? Okay, and there is another thing is that what we want to do is whenever the switching happens in this architecture, whenever the switching happens, what you want to do is this Kinesis data stream has all the data, right? So what you will do, let's say this go down at 3 p.m. and you switch to it. You switch to solution, you switch to architecture in region 2. What you want to do is you will start the data from 2:55 p.m. just to ensure that you do not lose any data. But it is a possibility that there is some duplicate records because you are going back in time and consuming the records from there. So just to ensure that there is no we do not have any issue in our system, your system should be idempotent, and we should have some kind of mechanism in place so that we are handling the duplicates properly. Got it? So this is the idea around this particular use case. Let's move forward with our client failover. This we have discussed. Okay, where we were. Okay, the duplicate scenario we already discussed. So in the second paragraph, what we are discussing is, so in case the data will be durably stored in primary data online and can be read from. Note that if the stream is unavailable for a longer period of time than total retention period of data stream, the data will be lost. Again, there is one more thing that the data will, for Kinesis data stream, the maximum time is 1 year. So if the Kinesis data stream do not comes back online for a 1 year, and let's say you have a use case where you have some data here D1 and you have some data D2. Okay, this is and this is replication going on in between. There was some data which we missed in here, and let's say this Kinesis data stream do not comes back online for more than 1 year, then we have an issue. There might be some scenarios with the data loss. Definitely this again is a configuration kind of thing that can we sustain that. It is rarely that a system or the system which is maintained by AWS will be down for 1 year, but we can assume that it will be not. Okay, if we are using AWS cloud, we can be good to ensure that it will be not down for that long. There is some SLE guarantees which are provided by every service, and it is not as long as 1 year for any of the applications which are supported by AWS. The another thing is the state management. We mentioned that for state-led application, it will be easy to switch from region 1 to region 2. Right, there are consumers running, but we are ensuring that these consumers do not require any state of the previous systems. It is not storing any state to process the data. But if it is, then you probably want to publish that state to, let's say, Amazon S3, the Amazon S3 as an object storage where these consumers can pull up the data from, so that it can start from wherever the previous consumers were left off. Got it? So this is the another thing which has to be considered for state management. If the state is required for the system, if the systems are stateless, then definitely it makes our work easy. Moving forward with the failback. So failback is like once you have moved from region 1 to region 2, now once the region 1 comes back online, you want to switch back to region 1, right? This is only your failover mechanism if the region 1 is not available. This is any your primary region, this is your secondary region. So if primary region comes back online, then what you want to do, you want to switch the traffic back again to this. And what you can do, instead of doing automation, what you should do is you should ensure that you can do it manually, obviously, in the times that there is minimal traffic being served in your system, right? So that way it will ensure that the RTO and RPO values, if the traffic is less, the customers are not impacted in very higher sense. And again, like since we are doing this, the consumer application region B is disabled and the replication to region B is resumed. Got it? We disabled in region B and then we move to region B. This is the helpful if we are setting up the architecture by your own. And definitely if you want to try, you can try it and you will learn a lot of things doing this. In this video, we'll be specifically discussing till now only. This video, I know there involved some of the concepts around AWS cloud, but I tried to keep it generic around how you can keep your architecture or re-architect your system so as to ensure high availability in your architecture. What kind of replication mechanisms you can install, how you will replicate, or like this is the general idea. Like if your resources in region 1 goes down, then you have to have resources in another region so that they comes back online and serve your customer traffic, because we don't want to hamper the customer experience. So in this video, it is all we are discussing now. We will meet again. By the way, if you have not subscribed to channel MsDeep Singh, consider subscribing and you will learn a lot of things around system design and distributed systems. We will meet again in our next video. Till then, stay safe. Tata. Bye-bye.